In this video, we're going to do some more examples with empirical and theoretical probability. And what we're looking at here is something called the law of large numbers. It states that if we do more repetitions of an experiment, we will get an empirical probability that is closer to the theoretical probability. So in our examples up here, our empirical probability that we found was 20%. You might have found something different if you did this experiment on your own. But our theoretical probability was 25%. So they were pretty close. There was only a 5% difference. But the number of trials that we did was only 20, and that's really not very many. If we did more trials, we would expect to get something closer to this 25% theoretical probability. So we're going to look at this applet here. I'm going to click on this link, and it will bring up this website that looks like this. And what we want to do with this website is we are going to change the number of trials to 10 and run our first simulation. So if I look at this here, I can see my, what I'm doing here is I'm flipping a coin, and my probability of heads is 50%. That's my theoretical probability. If I do 10 trials here and run my simulation, I can see that I got tails the first few times, and then I started to get more heads gradually. I approached that 50%, and then it kind of went back down. So now I'm going to try again with 20 trials. So 20 trials, I see that I'm kind of hitting that 50% mark a few times, going back down to a lower number, and then I kind of gradually start to bring it back up closer to that line. Now I'm going to try it with 100 trials. Click Run Simulation again, and I can see this time I started with heads, and then I had a sharp decrease, and then I had some sort of ups and downs, but it's gradually sort of right around this 50% line. It's actually a little bit above it, but you can see that it's kind of leveling off here the more that I kind of go out here and increase my number of trials. So lastly, I'm going to do the 1000. Click Run Simulation again. So now I can see that I have a lot of jumps at the beginning. It's kind of going up and down, but as I increase here out past 500, it's really sort of leveling off right here. And it's still not 50%, it's a little bit below 50%, but it's much more level as I have more trials than it is at the beginning. So that's the idea of the law of large numbers. As I increase the number of trials, I'm more likely to get a number that's closer to that 50%. So there are a lot of jumps at the beginning, but as the number of trials increases, the probability gets closer to 50% and levels off. Okay, so now we are going to look at possible sums when we roll two dice. So first we're going to fill in our addition table here. So we are adding the column and row. 1 plus 1 is 2, 2 plus 1 is 3, etc. Go ahead and pause the video if you like, or fast forward as we fill this in. Okay, so now we're going to calculate the theoretical probabilities. Our first one is that I roll two dice and a sum of 7 turns up. So I'm going to look in my table for all of the situations where the two numbers that I roll add to 7. And I'm going to highlight those 7s here in yellow. As I can see, there are 6 of them. So there are 6 total ways to roll a 7 out of 36 total possible rolls. And so my probability is 6 out of 36. Now I can divide that on a calculator and get a decimal, but I'm going to want to simplify the fraction for the homework because the homework is going to ask you for simplified fractions. It won't mark correct an answer that is written as a decimal. So I'm going to look at those two numbers, 6 and 36. They can both be divided by 6. 6 divided by 6 is 1, and 36 divided by 6 is 6. So my answer is 1/6. Question B says you roll 2 dice and a sum of 11 turns up. So I see there are 2 11s in my table. I'm going to highlight them in a different color here. So rolling a 5 and rolling a 6 will give me a sum of 11. So there's 2. So 2 out of 36. 236. Both of those numbers can be divided by 2, and that gets me 1/18. Our next question is you roll 2 dice and a sum less than 4 turns up. So less than 4 means that it can't be 4. It could only be 3 or 2. So I'm going to highlight those in my table. The language here is important. If it said 4 or less, then I could include 4. But it's not 4 or less, it's less than 4. So less than 4 means it can't be 4. So there are 3 numbers that are less than 4 in my table. So 3 out of 36. And if I divide both those numbers by 3, 3 divided by 3 is 1, and 36 divided by 3 is 12. Our next one is you roll 2 dice and a sum of 12 turns up. So we only have 1 12 in our table. I have to roll 6 and 6 in order to get 12. So the only way is 6 and 6. That's 1 out of 36. And that fraction cannot be simplified, so I would just leave it as that. You roll 2 dice and a sum of 13 turns up. Now, since I'm only rolling 2 dice, they're regular dice that are numbered 1 through 6, there's no possible way to get a 13 if I'm rolling 2 dice that are numbered 1 through 6. So there are 0 13s in my table. So my probability is 0 out of 36, which equals 0. So if it is impossible for something to happen, then the probability is 0. The next question says you roll 2 dice and a sum less than 13 turns up. So again, given that these are our standard dice numbered 1 through 6 and I'm only rolling 2 of them, all of my sums are going to be less than 13. So they are all going to be counted here. So this has a probability of 36 out of 36, which is 1. So if it is certain that something will happen, or if that it will definitely happen, then that means that the probability is 1. And so all probabilities are going to be numbers between 0 and 1. Sometimes we write them as percentages, but they would be decimals between 0 and 1. And the more likely something is to happen, the higher the number will be for the probability. So probabilities closer to 1 are going to be things that are more likely to happen. Probabilities closer to 0 are less likely to happen. And again, 0 means no chance, and 1 means it's definitely going to happen. So for question 4, which is more likely to happen, rolling a sum less than 4 or rolling a sum of 7? So if we look at our previous results here, the probability that that we get something less than 4 is 3 out of 36, and the probability of getting a 7 is 6 out of 36. So if we compare those two fractions, we see that 6 is more than 3 out of 36, and so the sum of 7 is going to be more likely. 6 out of 36 is greater than 3 out of 36. And so I'm using the unsimplified fractions here to compare them, just because it's easier to compare two fractions if they have the same denominators. So the sum of 7 is more likely to happen in this case.